My name is Daniel Brown. I'm currently in an Internet Tools Technology class. My major is Industrial Technology with a concentration in Industrial Supervision. And briefly, for my final project, I would like to show you the world of self-driving cars. My table of contents, which includes what is in my presentation, will be in the introduction, important parts of the car, which is a picture, how the car works, a ride in the self-driving car, which is a short, brief video I'd like to share with you, the advantages of the self-driving car, how people feel around the world about the self-driving car, and a chart that will prove my theory, and works cited page, which is where I gathered some of my information from. So at the beginning, I would like to share with you a few quick points about the introduction and about the rest of my presentation. The world of self-driving cars could be faster than anyone could ever imagine, and I think everyone could agree with that. The advancements that companies have made over the past decade is going to make it possible for people to reduce the cost of travel, allow minors to travel without adults, relieve people from having to drive, and make travel so much safer. There are a couple specific parts about the self-driving car I would like to point out, which are how the car works and the advantages of the self-driving car. Right here, I would like to show you a picture of the self-driving car and some of the key components that make it run smoothly. First off, you have the radars, which are in the front bumper and the back bumper. You also have the laser, which is one of the most important parts of the car. You have the wheel encoder, the GPS, and of course an awesome spoiler and a safety driver, which does not really do anything except monitor right now. But once they make these cars to the standard that they need to, they won't even have to monitor really. So here I'm going to talk a little bit about how the car works. The laser sensor on top of the car is one of the most important pieces of the car. The self-driving car works by using lasers, sensors, and cameras to detect objects and its traveling path in all directions. The most important feature on these cars is the laser sensor that rotates on the top of the car at 360 degrees, which detects millions of data points per second. There are also a few other sensors on the car, which are located on the front bumper to detect cones or other items in the roadway, one in the back bumper to help detect items when driving in reverse, and the ultrasonic sensor located on the top wheel to help the GPS mapping position, which is a position estimator. The camera is located beside the rearview mirror, which detects and sends information through data imaging programs to help identify signs such as stop signs, stop lights, etc. I would now like for you to watch this short video, which gives you a more exact representation of how the car works. Let me click on this right quick, and I will show you a little bit about how the car works. And I don't think I'm going to show you all of the video, but here it is.
For a vehicle to drive itself, it needs to know where it is in the world, and it also needs to know what's around it. Based on these factors, it needs to be able to make smart and safe driving decisions in the real world. And once you get in the car, you start to get a real feel for the way the technology works and what it's like in real driving situations. So there are a few things that have to happen before the car can safely drive itself. First, it has to figure out its location in the world. So we use GPS, but GPS isn't always that accurate, which is why we rely on our other sensors like the laser, which picks up on details in the environment that help us identify our more precise location. So think of the sensors as the car's eyes and ears, but with eyes that can see far off into the distance and 360 degrees around the car. And the great thing about having all these sensors is that they can talk to each other and get cross-checked information about the environment. So while we take in a ton of information using our sensors, it's our software that really processes all of this and differentiates between objects. All these objects are visible on the laptop that the safety drivers use while testing the vehicles. Based on what the vehicle senses and processes, these objects will be represented by different colored boxes. Cyclists will be red, pedestrians yellow, and the vehicles will appear as either green or pink. These boxes demonstrate the processing that takes place within the software. And think about the complexity here. People look different, cars have different shapes and sizes, yet despite these nuances, the software needs to classify these objects appropriately based on factors like their shape, movement pattern, or location. For example, if there's a cyclist in the bike lane, the vehicle understands that this is a cyclist, not another object like a car or a pedestrian, so the cyclist appears as a red box on the safety driver's laptop, and the software can also detect the cyclist's hand signal and yield to them appropriately. When our engineers think about where the car should drive and how, safety is always the top priority. So the vehicle takes into account many things like how close it is to other objects, or matching speed with traffic, or anticipating other cars cutting in. For example, as a passenger, it can feel a little uncomfortable passing by a large vehicle on the road. Our engineers have taught the software to detect the large vehicles, and the laptop shows them as larger boxes on the screen. As our vehicle passes by a large truck, it will actually keep to the farther side of the lane and give ourselves a little bit more space. We've also taught the vehicle to recognize and navigate through construction zones. The vehicle sensors can spot the orange signs and cones early to alert the car of any lane blockage ahead, and then we can change lanes safely. Another thing that's really important is for the vehicle to drive in a naturalistic way, because when it's natural and the car abides by social norms on the road, it's also safer. For example, at four-way stops, people typically rely on eye contact to communicate whose turn it is, and in our case, the vehicle inches forward into the intersection to indicate its intent. So my role as a safety driver is first and foremost to keep the car, myself, and everyone around me safe. And in addition to keeping the car safe, I also provide detailed feedback to developers and let them know the car does anything that maybe I wouldn't have done personally. Maybe the car wasn't assertive enough in a lane change or wasn't fast enough at a green light. We provide the detailed feedback so they can fine-tune the whole driving experience. By getting out there and driving in the real world, we're getting a better understanding of what exactly it's going to take to improve the safety and comfort and ease of transportation. And that's really what our project's all about.
So I hope that gave you a little bit more of an exact presentation of the key components that make that car run. And seeing that the bicycle is coming off the road and stuff shows those radar, that sensor in the front working, the GPS that you saw through that computer of the car going back and forth will show you of how the GPS is using is running in the car, and how far and how easy they are coming along with making this car. It's not an easy process, but as they continue to drive, I think they will get farther and farther along to where this could be a well safer way of driving and a way of living than having to drive your cars every single day. Which leads me to my next point of well, it's not working. The advantages of the self-driving car. There are two major advantages of the self-driving cars, and they are fewer accidents and decreased traffic congestion. The number one cause of accidents today are because of driver error. Alcohol and drug consumption totals about 40% of the accidents in the USA today. If self-driving cars were available, it would almost completely deplete the percentage. This website that states that the ENO study found that 10% of all cars were self-driving. As many as 211,000 accidents would be prevented annually. Some 1,100 lives would be preserved, and the economic cost of automobile accidents would be reduced by more than $20 billion. The next point is decreased traffic congestion. Is another benefit to having self-driving cars. One of the reasons why we have such high rate of traffic jams is due to the fact of selfishness in humans. I hate to say it, but I'm a little selfish sometimes too. If people would have more room in between them and the car in front of them and let traffic move in and out, traffic would flow a lot smoother. Scientists have proposed the previous theory to countless numbers of groups, and they always respond with, everybody would get in front of us. Some smart cars could be programmed to leave plenty of distance between cars, which would let traffic flow smoothly as people needed to switch lanes and exit highways, causing less traffic jams and faster travels. This right here is how people feel around the world. How do consumers feel about the self-driving cars? And as you can see, the percentages of respondents who are likely, unlikely to try a self-driving car. In India, you have 56% would say very likely, 29% is likely. China, 43% is likely, 32% very likely. Very small percentages in all all countries. Think that it's neutral, unlikely, or very unlikely. Very likely and likely being huge percentages in, like I said, India, China, UAE, France, USA, United Kingdom, Germany, and Japan. Right here is my works cited page, which you can see in the hyperlinks of two of my slides to where you can click on them and it will take you right to the website. I hope I've shared a little bit of information with you on the self-driving cars and how they are coming really fast. Um, these cars, I would like to say that these cars will one day be available to the public, and they are all will change the world as we know it. After seeing this presentation, I hope that you understand a little bit more about how these cars work and what some of the advantages of having these cars are. The more you know about these cars, the better we can prepare ourselves and prepare others for the biggest change in our lives in the automotive world. I hope you are as excited about this technology as I am, and hopefully within the next decade, we'll be able to drive and see a new world and a safer world and a better world due to it. Thank you, and I hope I have gave you more information about this topic to your needs. Thank you, and I appreciate it.